Hello everyone, Mr. Schultz here. Please make sure you write your information in the top left-hand, right-hand corners, okay? So we're going to talk about our notes representing relations. Whenever we have two different bits of data, we can relate them. This is a relation. So for example, the number of days in class we've had, as well as the amount of time spent doing homework. So these relations can be represented in different ways. For example, we have ordered pairs, we have a table, graphing, as well as mapping. In each of these cases, they represent the relation between the two sets of numbers. In some of them, it's easier to understand what is happening. In others, it's easier to understand other things that are happening. Let's continue. Before we get into the example one other final way to show a relation is in an equation, such as y equals x plus 1, x plus 2. Sorry about that. Let's go on. Example 1, representations of a relation. So we can represent a relation as a table, a graph, mapping. So for example, we could write this as a table right here, an XY table. So what I like to do is I take this information and then I input the values. So for example, I'm going to go from less to greater, starting at -4, and then it maps off to -4. Then the next one going up is -2, it maps to 3. Then 0 to 4, and then 4 to 0. Now I like to do mapping as well. So with mapping, we have the domain and the range. Also right here, this is like the input-output. If you didn't notice up here, I had input-output, but they like to call it domain and range, which is the input and the output. So let's write that in. The domain and range, also known as the input and the output. So once again, you only need to write down the number once, but none of these numbers repeat, so we're pretty much writing them down again. All right, so we put -4. Oh, the one thing that I will do is I will put it in order. It goes from -4 to 0 to 3 to 4. And so what we would do is we'd map the inputs to their outputs, like so. 0 maps to 4, and 4 maps to 0, like so. Now, one thing that I wouldn't do on white sheets of paper or lined sheets of paper is I wouldn't graph it. I mean, if I did graph it, I would see 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I wouldn't see a very clear outcome of what's happening. I mean, -2, 3. I would get a rough estimate of what's happening, but not like a clear indication of what's happening, because I can't really draw graphs that well. I probably want to use graph paper to actually draw my graphs. Alright, let's go on. Before we go on, I would say I would write this for the domain and the range. I would say the domain would include -4, -2, 0, and 4. Whereas the range, the y value, the output, is -4, 0, 3, and 4. There we go. Let's go on. So here we go with example 2, analyze graphs. So the graph represents the amount of Seth's paycheck for different hours of work. So identify the independent and dependent variables. Alright, so first things first, the x value is going to be, unless we graph it wrong, the x value is going to be our independent value. So the hours Seth works is the independent variable. What that means is the amount of money he earns, which is his paycheck, depends upon how many hours he works. So that's his independent and dependent variables. One depends upon the other one. All right, describe what happens in the graph. All right, well, Seth is working a set of hours, and he is earning money at a constant rate. How do we know that? Because it's a straight line going up. I mean, not going up, but like at an angle. All right. However, after a certain amount of time, this rate of pay increases. So this is probably he's going into overtime probably. So instead of just going up like this, now all of a sudden it's going up even more. His rate of pay has increased. Let's go on. So, example 3. Use appropriate scales. So if we're going to graph these, we'd have to understand a few basic things. The domain minimum, domain maximum, range minimum, range maximum. Oh, let's just say maximum right here. So let's cross this off and say maximum. So looking at this, it looks like my range goes from negative 91 to 95. And it looks like my x value, my domain, goes from 5, nope, negative 36. Yep, looks like the lowest one is negative 36. And the highest is 38. So if I was going to use some appropriate scales, I'd probably go from, I'd round down or round up depending. If it's a minimum, I'd round down. If it's a maximum, I'd round up. I'd probably want to go, my x values be negative 40. So here's the domain. The domain is going to be in between negative 40 and 40. Now my range, I'll probably have it between, round down, negative 100 to 100. Well, let's go over there. Let's go to Desmos and look at it. At the moment, these are all graphed, but you can't tell until I zoom out. So there's a reason why we want to have certain bits of data. Alright, so I already said I want to go from negative 40 to 40. And I want to go from negative 100 to 100. Now if I do this, I should be able to see all the points. These are all the points. I can read them for the most part, and it's good. Now we want to make sure that we're using good steps. Now what does that mean? Well, I can change this and say, okay, I want it to go 2.5. Well, if I do that, all of a sudden, certain points in the graph stand out. Like I could say, hey, I want to make sure that I see every single line. I could do that. It's okay. Let's go on though. Alright guys, so now we're going to talk about example 4. Choose an appropriate origin. So origins, means where you're starting your graph. So if we're going to be starting this graph, we have our x and y origin. Now this is going to be 0, 0, but what does it mean? Well, it looks like 2005 to 2015, it looks like it increases by 1 each time. So I'd probably want to have a scale of like 1, 2, 3, 4. So a scale of like x scale would be 1. And then looking at my snowfall, it looks like I'd probably want to go up by, the highest number is less than, it's about 43. Well, I'd probably want to do every 5 or so. So the scale for the y would be 5. I'd want to go up to 45. And so I'd probably have like 9 of these going up. It just depends on what looks good when you're graphing. Now, I'd want to go up to 15 right here, or not to 15, but 1, 2, 3, or 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'd want to have probably my 10 going up. But what is my 0, 0? Well, my 0, 0 would be, my origin would be, the origin would be years from 2005. So at 0, 0, it would be at 2005 for the x, and y would be the snowfall in inches. I'd want to test a scale of 1 for x and 5 for y. Now, if it looks like it was too scrunched for the y, I'd probably like test out different ones, maybe 2, maybe 1, see if that works. I probably wouldn't want to go 45 all the way up by once. All right, let's go on. So this is what it would look like. See, they're going by 1 year since 2005, and they're like 1, 2, 3, 4, and then going up, it's inches. You can read this. Now, if we stretch it out too much, it's going to be hard to read. If we stretch it out another way, it's going to be hard to read. In either case, we're trying to find a scale that makes this easier to read. All right, let's go. Before we go on, make sure that you have a title on any table or graph that you make. Let's go on. So this last one right here is interpreting scales and origins. So let's answer this question. Supermarket. The number of items that 8 customers bought at a supermarket and the total cost of the items is given in the table. Interpret the meaning of axes, scale, and origin of the corresponding graph of data. All right, so let's break it down. Okay, well, we know that the axes, the x-axis is the number of items bought. The y-axis is the total cost in dollars spent. All right, well, next up, it asks, what about the scale? It looks like the scale is 1 for the x-axis, but if you look up, it looks like it's going to be 0, 2, 4, 6, 8. It's by 2, but is 2 for the y-axis. All right, next up, the origin. Well, nothing changes on this one. I mean, the total cost is always going to be 0, and the total number of items is going to be 0. It doesn't change anything. We didn't say, hey, this is the amount from 10 items, so it'd be like to 12. No, they only had this many. So the origin would be 0, 0, 0 items sold, and the cost being $0. All right, there we go. All right, guys, we're done with 3-1. I hope you guys have a wonderful day, and I will see you in class. Goodbye.